Okay, we're gonna go over the blower motor operation on an 01 Chevy truck. The blower motor only works on high, it doesn't work on any of the other speeds. This is a repeat problem. About a week ago, it had a new blower motor resistor installed. It fixed the issue for what, 2 days? Yeah, so for about 2 days, and then it quit working again. So we could just be dealing with a failed new part. It was an aftermarket part, or we could be dealing with a root cause that got missed last time. So that today, me and Albie are going to go through that and figure out what's going on. So first, we're going to go through our diagnostic procedure one step at a time. So step one is identifying concern and symptoms. We already did that. So now we're going to take the time to understand the theory of operation and how the systems work. So, Albie, you want to explain that?
Switch is where we get all our feed from. This is our...
For which speeds?
For all speeds here.
All speeds,
yes.
Right? Okay.
That goes to the resistor. The resistor sends out signal to the motor. So I think the best place to start would probably be checking power on all of our different feeds. And that'll tell us
at the resistor,
right? Yep. It'll tell us if our switch is working correctly.
And you see what happens when you switch it to high? So when you switch it to high, that circuit actually feeds the solenoid side of a relay built into the resistor, and then that switches for direct power from a different fuse to feed the blower motor. And you can see that this is the front HVAC fuse and the underhood fuse block, and the power for the rest of this comes from the heater AC fuse in the left lower side of the dash. Now we can already rule out a certain amount of things based on the diagram and what we know happens, right? So we know it only works on high, right?
Yep.
So if it only works on high, is it safe to say that this fuse is probably good?
Yes.
Okay. Is it safe to say that fuse is probably good?
No.
Why not?
Because these ones aren't working.
These ones aren't working? What's turning that relay on then?
Should be this one here, correct?
Yeah, so where would it get power to turn that relay on from?
From this side.
From this switch?
Yes.
Or from that fuse?
Power, yep.
So it's probably safe to say both our fuses are good.
Okay.
And then if it only works on high here, and that we know that circuit works, and we know this circuit works, so are we going to just check with a test light on all 4 of these other wires, right?
Yep.
And then if all those are good, we know that all of these resistors failed, right?
Yeah.
Okay. And if we're going to assume that all these resistors failed, either it's a low quality part or we have an excessive amount of current draw from our blower motor, right?
Yep.
Okay. So let's get to testing then. I'll kind of work over your shoulder then while you work.
Excuse me, I gotta grab a pick.
Yep. When you get back in there, you're gonna want the key on, right? Hot in run. So we're gonna need the key in the ignition run position. So you want to make sure you have the key on, Albie?
Yep, I was gonna unplug this. So you want to back probe it or unplug it and check it from front?
However you want to do it. If we're using an appropriate test light, it'd be okay. So you can go ahead and just unplug it, right?
Yep.
For now.
Test light.
There's the connector, blower motor assembly. So that's where we're going to do our testing. Ground that test light.
One.
Okay.
And one should be what color?
And 1 or low is going to be the yellow wire.
Second one in.
Double check. Make sure this is.
Make sure you have a good ground. And if we're wasting too much time, where's the best place to go?
To the battery.
Right.
There we go.
Alright, so now we know we have a good ground and we have it good on yellow. Alright, so let's go to the next one up, which is going to be the tan wire. And we have a test light on that, okay. And the next one is going to be a light blue wire. And that's good. And the next one is the purple wire. And that's good. The next one is the orange wire.
That's high.
And both the orange wires should light a light.
One of them are.
Check your purple wire again.
Nothing.
All right, turn your fan speed down. Did you lose your ground?
Yep.
All right, so that's a real life problem. So that's how we can mess up our testing. You can see as he's wiggling that ground, we have good ground, bad ground. Okay, now you can change it back to high and check both your orange. Okay. Alright, so we have all of the voltage where we should have it, when we should get it. And our blower motor still doesn't work. Well, it does work on high only. So we know more than likely that resistor just failed. So now we're going to check the blower motor current draw using the lab scope to determine if the blower motor has excessive current draw. So we're going to get that set up really quickly. Is that going to reach?
You don't have to do it, right?
It really doesn't matter. Make sure you turn it on yeah, sorry. Slide all that over. Okay. We're going to set the scope up.
Turned on to 20 or 60?
You're going to set it up for the 60 low amp.
It's on.
Okay, go ahead and push.
Zeroed it.
Yep, you zeroed it. Good. Okay, and then put it on the red wire with the arrow facing the blower motor.
Yep.
Okay.
You're on there.
Yep, and go ahead and turn it on high.
On 20?
No, turn the blower motor on high.
Oh, gotcha.
Yep, keep that on 60.
It still is, yeah.
Okay.
Motor's on high.
All right, and I think you might be backwards. Yeah, so go ahead and flip that over.
That's arrow pointing towards the fan.
Oh, never mind, that was my fault. Okay, that's good. So what we're seeing, so what I want you to do is shut it off and then start it back up. We're going to take this all the way out to 20 seconds. All right, go ahead and start it back up.
2, 3, 4, 5.
All right, see that peak there is the amount of force that it takes to start the blower motor. And you can see that's as high as 54 amps. So that blower motor probably has a bad bearing. You know, that's binding, or it's binding on startup. We're going to compare that to the new one and see if that's our problem. but that seems like a pretty high starting current for this. But now with that still running, we're going to take this down to about 500. And here you can see the amperage draw of the motor is running right around 13 amps, and it's relatively smooth. It doesn't have to be absolutely perfect, but you can see all those humps is as the brushes hit the commutators on the armature. That's the current draw increasing and decreasing as it goes from commutator to commutator on the armature, and all that looks really good. You watch, we can even get this out a few. We could even get this really narrow if we want and really get a good look. And then zoom out just a little and get a good look at how that looks. So I feel pretty good about that. You know, as far as electrically, it looks fine. You know, but the startup is what's got me a little concerned. So you can see, we'll back this out to 20 seconds. Go ahead and shut it off, and then when I tell you to, go ahead and turn it back on. Back up to 60. All right, go ahead and turn it on. You can see that shot all the way up to about 50 amps to start the motor turning. So then we're gonna replace that blower motor and replace that resistor again and see if it makes a difference on what it takes to start that blower motor. All right, so we're just gonna go over this while Albie gets everything changed. So we looked at the theory and operation. We know how this works. We used the information gathered to test it. We went through the testing procedures. It does seem like the starting amperage, or the amount of current it takes to start that motor turning, seems a little excessive. So that's probably what took out the blower motor resistor, but we're going to prove that by replacing the blower motor and replacing that resistor yet again. And then we're going to go back through, document, and we're going to go back through and prove that. We're going to confirm that we fixed this vehicle before we're done here today. So I just want to get a good shot of that. We keep these right on our clipboard so we don't get sidetracked in how we diagnose these problems. Okay, so now we've got the blower motor all set up. You got it on high right now?
No, I got it off.
You got it off right now? All right. What you're going to have to do to get it to start on high is shut the key off, turn it on high, and then turn the key on.
So high, keep it on.
Flip the clamp over, do it again. Put the clamp on upside down.
Going towards the motor.
On the black wire?
Yep.
That's the ground.
Oh, God. Well, last time you said it didn't matter.
No, it doesn't matter, but it matters which way the current's flowing. All right, go ahead and shut it off.
Off.
All right, and we're going to turn it back on and see that starting amp. All right, and that one is also about 50, but I don't know if you could see the difference in the amount of time it took. You'll have to go back in the video to see, and I might be nice enough to cut it in so you can see the difference. And this one looks like it's running on high a little bit lower in as far as current flow. Let's see what we got here. So the other one was about 13, and this one looks like it's right around 10. We'll just pull up the digital. Yeah, right around 10. Where go ahead and shut it off and turn it back on again.
All the way off?
Yep, go ahead and turn it on. Yeah, and we had about 43 amps as far as startup current flow. And then we'll zoom in here and take a look at what that motor looks like compared to the old one. You can see those lines are a lot smoother on the on here. You can see that's a lot more consistent, a lot smoother. So this blower motor is going to last a lot longer, and it's not using as much current to maintain. So that means on the lower settings, these resistors will stay cooler because they'll have less current flowing through them, and hopefully that the new aftermarket resistor won't fail. So that's what we're going for. That's what we're hoping for. Like I said, you can see a little bit on the time base how much longer the other one was taking to start. Not a whole lot longer, but hopefully that takes care of our failure issue. And we turned the old motor by hand, and it does seem to turn a little more. Takes a little more effort to turn than the new one. So that's the end of this. Say thanks, Albie.
Thanks.
Thanks for watching.